Hi everyone. In this session, we are going to learn about parabolas. So, if you are somebody who is appearing for the selective exam, then this is very important for it, especially when you are appearing for the selective exam in year 8 for the admission in year 9. So, this topic is very important and crucial. So, let's see and dive into it. How much we can understand from this parabolas is what we need to know. Okay, so what are parabolas? These graphs are generated and they represent the quadratic equation. So the minimum quadratic equation that we can form is y is equal to x square, because you know that quadratic equations are of the form ax square plus bx plus c, where a is not equal to 0, because if a, that is a coefficient of x square, becomes 0, then this would not be the quadratic equation. Hence, we need to just check that a should not be 0. Other than that, anything is good to go. Now, let's see that if I'm going to plug in the values of x, and what are we getting the values of y with respect to that x. So if x is 1, let me start from 0. Then you have 1, 2, 3, and then you have -1, -2, and -3. So we know that 0 square would just be 0, 1 square would just be 1, 2 square would be 4, 3 square would be 9, minus 1 square would still be a 1, minus 2 square is still be a 4, minus 3 square will still be a 9. So we can very well see that the range is always positive given any domain, be it positive or negative. So that's what we need to understand over here, that we will get the same values of y, be it a negative x or a positive x. So if I'm going to plot them up, I saw that on 1 I'm getting 1, and on -1 also I'm getting a 1. Similarly, when I plot 2, so at 2, at x2, we are getting y as 4. So I'm going to plot it. Then at -2 of x, I'm getting 4 again, plot it. Then at 3 of x, I'm getting 9. So let me just plot that also. At -3 also, I'm getting a 9. So plot it. Now I'm going to connect them up, and the figure that you're going to see is going to be that of a parabola. This graph represents the shape of parabola. This is an upright parabola which is open from the top, and the minima lies at the vertex over here, because any upside parabola would have a minima and any inverted parabola would have a maxima. So these are the features of the parabola, and we are going to find out what all features do we have. So the vertex, as you can see, is 0, 0. Vertex means where the parabola changes its direction. So its direction gets changed over here at this point. That is the vertex. Then it is a minimum parabola, as I already told you that this has got a feature of minimum. This is a minima point. Then axis of symmetry. Axis of symmetry, you know, if there's any figure and we have a mirror image of it, of the left hand side at the right, or the mirror image of the right on the left, that means they're equidistant on either side. That makes the axis of symmetry. So over here, this x is equals to 0 is the axis of symmetry. Then we have y-intercept. Y-intercept is where the parabola is going to cut the y-axis. Now here again, this all is happening at the vertex, so 0, 0 are the is the y-intercept. Similarly, x-intercept is also 0, 0. So everything lies over here on the vertex. But with the transformations, these all things will change. So we'll see how the transformations happen in the parabola now. The first transformation is that of a reflection. That means if I have formed y is equal to x square, now I'm going to form a parabola that will represent the minus x square. Let's again put the values at 0 of x. The x square would be 0 and minus of x square would be 0 again. So at 0 we are going to get a 0, that's for sure. Then at 1, if I'm going to put x, 1 square is 1, but negative of 1 square is negative 1. Similarly, 2 we get a negative 4, and at 3 we get a negative 9, because 3 square is no doubt 9, but negative of 3 square will be negative 9. And there's a difference between minus 3 square and 3 square and minus of 3 square. You should be very well aware of it, because minus 3 square would be 9, 3 square would be 9. However, minus of 3 square would be minus 9, because minus is outside of the bracket. This is what you need to learn. Then if I'm going to negative 1, so negative 1 square is again 1, but a negative is there outside, so it will be a negative 1. For minus 2, again minus 2 square is 4, but negative of minus 2 square would be minus of 4. Minus 9 squared, sorry, minus 3 squared to 9, but a negative is outside, so minus of 9. Now you can see we are getting all the inverted values of y. So I'm going to plot again minus 1 by minus 1, and also 1 you're getting a minus 1. At 2 you're getting a minus 4. So let's see here. At 2 we are getting a minus 4. So here. So then 3 we are getting a negative 9. At negative 3 also we are getting a negative 9. So always make a table first and only then draw the then do the plottings. That would be very helpful for you. So this is the inverted parabola. This is a reflected parabola, whatever you want to say. It's an inverted parabola or reflected parabola, whichever is good to go. Correct. Remember, here the coefficient of x, that is a, is less than 0. And that's why you're getting an inverted parabola. Always this condition is going to be suffice, that whenever the coefficient of x, that is a, is less than 0, you will get an inverted parabola. Next transformation that we're going to study is dilation. Now for dilation, I have already gotten the values over here for you. So plugging in the x, we got all the values 1, 2, 3, 4, 0, minus 1, minus 2, minus 3, minus 4. Then again square them up. So we have squared them. Then also 2x square, that means 2 times of x square has been done. So what I'm going to tell you over here is, as the coefficient of the coefficient of x square increases and it goes beyond 1, your graph will come closer to the y-axis. So if a is greater than 1, it will come closer to the y-axis and it keeps on growing. So if a keeps on growing, then your parabola comes nearer to the y-axis. However, in the range of 0 to 1, in this range, if your um, a is there, that will take the parabola in a wider manner, means the parabola will start to get away from the y-axis. So we'll see how does it go. So I've plotted these values. You all also work them out and get the values. Pause the video, check your values from here, and then possibly draw the parabola with me. So now at 2x square, so first of all I'm going to go for a x square only. So we'll go for x square. So just simply plot the values of x square over here. Minus 2, minus 4, minus 2 by 4, and then 3, you're getting a 9. So at 3 we are getting a 9, at minus 3 we're getting another 9. So this is a simple x square graph. But different graph is going to come up now, that will be for 2x square. So at 1 we are getting a 2, at 1 we are getting a 2, at 2 we are getting an 8. So at 2 we are getting an 8 here. This is very important to understand over here. Negative, at negative 1 we are getting a 2 again, and at -2 we are getting a 8 again. So you see this parabola, if I'm going to draw for you, this is little closer to the y-axis. As I told you, as a keeps on increasing further, the parabola keeps narrowing towards y-axis. Similarly, if the a is lying between 0 and 1, so let's say half of x square. So for this, I'm going to plot now. I'll take a different pen for you. Here you go. So at 1, we are getting a half. So at 1, we are getting a half. Plot here. At 1, we are -1 also, we are getting a half. Plot here. Then at 2 we are getting half of x square as 2, because x square was 4, half of 4 is 2. So plot at 2 we are getting a 2 again. So here you go, and then -2 पे you're getting a 2 again. Here you go. Then you're getting a 9.9 over 2 at 3. At 3 and -3 we're getting a 9 over 2. That means 4.5. 4.5 is somewhere here, and -3 by 4.5 is somewhere here. So you see, this is how it is going. This is for half of x square. This is for 2x square. And for basic x square, we have this blue graph. So you see, if the coefficient is between 0 and 1, it shows wider parabola. If the coefficient goes beyond 1, like 2, 3, 4, so it will come closer to the y-axis, which is, as you can see, 2x square is a slightly closer to